All right, so talk to me. I want to solve this, or I want you to solve this using any method you choose. So examples of different possible methods. We've got guess and check. You could make a table. We could draw a graph. Or any of the analytic, the algebraic methods. So things that you learned in algebra for how to solve. That is a solving method. Sorry, not 90, 98. 98. What type of method would you want to use on this one? I'm sorry, one more time.
Is that one page where it's all a bunch of different ways to solve an equation? Like, is that a method? Does that count?
I don't know.
I forget what it's called, but it's like you're subtracting on both sides.
That would be one of our analytical methods or one of our algebraic methods. So you want to subtract from both sides? What do you want to subtract from both sides? Okay, let's subtract 7 from both sides. So what would I have remaining then? 3x equals, I'm sorry, I didn't hear your last. Negative 2. What would you do after that?
Divide 3x on both sides.
Divide by 3x?
Oh, no, 3, sorry.
Just 3. Because if we divide by the x also, it's going to cancel out on both sides. Is this the kind of thing that I would want to leave as a fraction, or writing as a decimal would be cool?
Fraction.
Why?
Because this is repeating.
It's repeating. If I put this into my calculator, it's going to be negative 0.6666666666666. I like to leave those as fractions. So x is equal to negative 2/3. So I'm curious. We say x is equal to negative 2/3. What did we just find? We did find x. Is that the only x forever and ever? Like, what's the meaning of this value for x? So if I take this answer, if I take negative 2/3, and use it as x, that makes it an input value. What would we find? If I take negative 2/3 and I put it in the place of x, what's going to happen? It's going to equal what?
5.
It's going to equal 5. So if I take negative 2/3 and I use it as x as input, my output, what kind of values are output values? If x's are my inputs, what are my outputs? Y. My output, or y value, will be 5. I want to look at that on a graph, because sometimes we can use these analytical methods, these algebraic methods to solve, and sometimes they break down or it gets too difficult. So I'm going to hop into Desmos. I'm going to put just the left side of this equation in, 3x plus 7. And we're going to find on the graph where it is equal to 5. All right, so I need to open up Desmos. And if somebody could read to me the left side of that equation, that would be super awesome.
3x plus 7.
3x plus 7. Okay, so there's the shape that it makes on the graph. 3x plus 7 makes what kind of a shape? It's linear. And I want to find where it's equal to what?
5.
Where it's equal to 5. So where do I look for output? Where do I look for y values on the graph? On the y-axis. So here's 5 on the y-axis. How do I find the x that would give me an output, a y value of 5?
Did you scroll up and it was like Like the line touching 5, we can check.
There we go. So this right here, I would want this ordered pair, and then I can follow that down. So here's 5. We know from our algorithmic work that this should be negative 2/3, right? Or what would that be as a decimal? Because I don't think Desmos does fractions. Yep. Negative 0.6 repeating. So this ordered pair right here would be negative 0.6 repeating, and then 5, right? I can click on this gear wheel right here, and it'll show me a table. And I can also use that table to approximate. So I can look at the graph. I can touch here, and I can try to get it, but notice it doesn't let me go right on 5. I can't get an output value of exactly 5. I can click on the gear wheel. Do you guys see the table right there? Mm-hmm. I can click on the table. We want an output of 5. Well, that's happening obviously somewhere between these two, right? Because here's an output of 4. Here's an output of 7. So if I try different things, I can use this to help me guess and check. Like, well, I know it needs to be in between -1 and 0, so maybe I do negative 0.5. That gets me 5.5. That's pretty close. Still want it a little bit smaller, so I probably want to go closer to -1. So maybe I do negative 0.6. That gives me 5.2. I can use this table to guess and check. On Desmos, the table will fill in the y part for me. If I just guess some y's, it takes my x's, it substitutes it in, and it calculates the y value for me. I want to look at the second one down on your page, and we're going to keep coming back to this because sometimes our analytical methods break down. Let's look at number 2. Oh, we didn't answer this question yet. What does it mean to solve? To find an x value or an input that gives me the desired output or y value. So I want you guys to pay attention as we talk about the different methods and the different ways of knowing. The homework, first homework of this new unit, first homework since break, due on Friday. It's only one problem, but I ask you to solving it using as many different methods as possible. So if you solve it and you only use one method to do it and you don't try anything else, you're not going to get full points for it. You need to try to approach it with as many different methods as you possibly can. All right?
So this is one of the methods?
One of the methods is an analytical method, yes.
And this is what we're doing right now.
Mm-hmm. One of the other methods that we just looked at was here. I can graph it, or I can use software to help me graph it. But that's only as good as my ability to interpret the graph. I need to know what I'm looking for on the graph once I've done that. Same thing with a table. I can use this table feature to help me answer the question, but if I don't know what I'm looking for, the table doesn't help me either. So looking at number 2, we want to solve this using any method. Tell me one way I could go about solving this.
A graph.
A graph. We will graph that. Tell me what else I could do. Analytical. What would that look like here? Give me a way that I could solve this analytically or algebraically.
You could add 5.
I can add 5 to both sides. Okay, what would I get after I add 5 to both sides? 3x squared equals 12.
You can divide by 3.
Divide both sides by 3. Yep, so I'd have x squared equals what?
4.
X squared equals 4, and then you said square root each side.
Then you get 2.
Close. How many answers do we get when we square root?
1 and 2.
Yes.
Positive 1, positive 2 and negative 2.
Positive 2 and negative 2, because when we take the square root of something, we get both the positive and the negative result. So x equals positive 2 and x equals negative 2. We are going to go look at this on a graph here in just a moment. We're going to look at the table 2. I want to look at another possible analytic way of determining these exact same two answers. What about if at the very beginning, instead of adding 5 to both sides, what if I subtracted 7 from both sides? Am I allowed to do that? So I could subtract 7 from both sides. What would that give me over on the right? Equals what? Equals 0. If we're setting it equal to 0, what method, what analytic method are we going to try here? Starts with an F. Factoring. So this is,
Greatest common factor, you could just
yes, what is our GCF here?
3.
GCF is 3, so I would take that out of each piece, but we don't throw GCFs away. It's going to stay out at the front. What would I have left over if I take a 3 out of each piece?
X squared minus 4.
X squared minus 4 equals 0. What do you know about this?
Put it in a box.
We can do that in a box. What did you say, Nasiba? Yep. This is a very special quadratic right here. What do you notice about each part?
It's a perfect square.
Yes. This is a difference of 2 perfect squares. So when I go to factor a difference of 2 perfect squares,
You can just take it out, like -2 and +2.
So we still have that GCF out in front. We get 2 factors when we factor a difference of 2 perfect squares. What's going to be the only difference between them, though?
One's going to be positive, one. Oh, this is
Mhm.
going to be switched.
Yep. One will have a plus sign, one will have a minus sign. Other than that, they're identical. And then because they're both perfect squares, I take the square root of each part. So I would do the square root of x squared, which is what? X. So each factor would get an x in it. I do the square root of 4, which is 2. And then what do I do with each factor if I want to solve it?
Double distribute it.
If I do that, I end up back where I started. What do I do with the factors to find my solutions? Set it to 0. Not a trick question, but be careful. How many factors do I have? 3. What are my 3 factors? Yep. 3 is a factor because it's greatest common factor. But if I set 3 equal to 0, can 3 ever be equal to 0? So that one doesn't actually make any sense. I take x plus 2 and set it equal to 0. I take x minus 2 and set it equal to 0. And then I solve each one of those. So what answers do I end up with?
X minus 2, X equals 1.
Yep. X equals -2. That was one of the answers that we got doing it the other way. And x equals +2. That was the other answer. So we got all the same answers, doing it a different analytical way. So there's more than one algebraic way to go about solving it. We're going to go look at the table in the graph now. And then you guys are going to do the next 2 problems. And don't shy away from using a graph or a table, especially if an analytical method breaks down. If you get stuck, use a different method. That's one of the reasons why we have so many different methods. right, so I'm going to go put this in my graph. I'm going to graph the left-hand side of it. And I want the output, the y value, to come out to be what? 7. So I'm going to go look at my graph. 3x squared minus 5. Come on. So 3x squared minus 5. And we want it to be equal to what again? 7. Where's 7 on my graph?
It's
A little bit higher. Okay.
It's like 2 spaces above 5. Oh, wait, is it go? Yeah.
So I'm going to bring it over here. So 7 is like right here, right? So if I draw a dashed line across there, how many places does that intersect with my parabola? In 2 spots. Once right here, right? And once right here. What are those ordered pairs? What would this ordered pair be? 2, 7. So here's the x value that gave me an output of 7. What would this ordered pair be? Negative 2, 7. So here's the other x value that also gave me an output of 7. So I can do it with a graph.
So you already got your negative and positive like that?
Mm-hmm. So I can use a graph, and from a visual perspective, if I know what I want my output to be, I know what I want it to be equal to, that's where I go on the y-axis, and I see where that intersects my graph at. Or I can use a table. Thank you, ma'am. I can click on the gear wheel. I can open up the table. What do you notice on the table? Yeah. Negative 2 has an output of 7. Positive 2 has an output of 7. I got lucky because positive 2 and negative 2 were on here, but if they weren't, I could click on an open spot and I can type in x values and continue to just guess and check with my table. So far, so good? All right. Number 3 and number 4 are a little bit more complicated, but I want you guys to look at those using as many of the different methods as we've talked about. If you get stuck on an analytical method, come and look at the graph. Go and look at the table. I'm going to give you guys about 10 minutes to work on these two. You're welcome to work with a partner. If you really don't like working with a partner, you may do it on your own. All right. Did anybody solve number 3 analytically? Did anybody attempt to solve number 3 analytically? Okay, so when you attempted to solve it analytically, tell me what you did.
There are perfect.
GCF. Do we have a GCF here? No GCF, okay.
I tried adding 9 to the 0.
Okay, so you added 9 to both sides?
Is that analytical?
That is an analytical method. Is that allowed? If you add something to one side, do you add it to the other? Yes. Does anybody remember what that's called? Addition property of, what's in between them? Equal sign. So addition property of equality. That's the official name of if you do it to one side, you do it to the other. Addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality. Shh. If I add 9 to both sides, we've already discussed that that is allowed. Does that help me get closer to my answer? Like, do you know where to go from there? Okay, so stuck.
Because I did that too. So I tried the Xbox.
So you tried the X box. I like that. So x squared plus 42x minus 9 equals 0. You said you tried the X box. So tell me what you wrote down when you did the X box. Negative what? Negative 9, because we multiply A and C together up here. 42 at the bottom, that's our B value. I need two numbers that would multiply to give me negative 9. How many different things can you guys think of that multiply to give you negative 9?
3.
Let's see, 3 and 3, and you said 1 and 9? If it's going to multiply to be a negative, one of them has to be a negative, right? Is the B value positive or negative? So that means the bigger number has to stay positive. So I'd make the smaller ones negative. If I add these two together, do I get 42?
Yeah.
AB is having trouble with addition. That's okay. What about these two? Negative 1 and 9, do I get 42? So does that mean no solutions? Just means I can't solve it this way. It's not the same thing as no solutions. It just means this method isn't going to work here.
42. That's cool.
So it does mean, shh, ladies, please, does mean this method won't work. So if this method won't work, what can I do? Graph it. Let's go graph it. All right, let's go look at that. So x squared plus 42x minus 9. Plus 42x minus 9. Okay. First of all, what am I looking for on the graph?
Yeah.
Where it's equal to 0. I want the y value. My desired output is 0. Does it ever hit 0 on the y-axis?
Yeah.
Yes. Where is 0 on the y-axis? This right here. The entire x-axis, the y's are all 0 across the whole thing. Does it cross there?
Yeah.
Yes. Is it a whole number?
No.
That's why we had trouble with factoring. It doesn't mean that it doesn't touch the x-axis, but it does mean that it's not pretty. Factoring only works when it's a whole number or a fraction. So what I see here is it's not a whole number, and it's probably not a fraction either. At least not a pretty fraction. I do know from the graph that it's in between what two whole numbers?
0 and negative 40. Wait, what?
That one right there is in between 0 and
Oh, sorry, 1.
0 and 1.
I thought you were talking. Sorry.
If I zoom in closer, could I get even more accurate?
Oh, yeah.
I can zoom way in there. Yeah, like I see right here that it's a little bit bigger than 0.2.
Oh my God.
And if I click on it, I can get even more precise.
Yeah, it says 20.
Oh,
Yeah.
Wow.
0.213. If you zoom in, it'll give you more decimal points.
That's crazy.
Is that the only place that it hits the x-axis?
Yeah. No.
The only thing I can see on this picture, but is that the only place?
Over there, by negative 40.
So Tristan said that it hits again, but I can't see it unless I zoom out. How did you know that we should probably zoom out, Tristan?
Because every other problem done has 2 equations, and when I first put it in, I saw it. It's a quadratic, so it's a U shape. So I know it has to come back and intersect.
It's a quadratic. It makes a U shape. How did you know from looking at it it was a quadratic? The x squared. If you see an x squared, if it has any solutions at all, it probably has 2.
Yeah.
So I can find this one over here. I could scroll in and get even more precise. I can see that it's in between what values?
Negative 42 and negative 43.
In between negative 42 and negative 43. And if I click on it, I can get more precise. Could I use a table with this?
Yes, it would not be fun.
You could click on the gear, click on the table. I would have to do some guessing and checking on the table. So being able to look at the graph is very, very helpful because it gives me some good ideas of what to guess and check with. right, so help me out. We found that x could be what?
0.2132.
0.2132.
Negative 42.213.
-42.213. And how did we find those again? By graphing. Used a Desmos graph. Oh, I can't spell Desmos apparently. Making up new words. Can we use analytic methods with number 4? Not really.
You can just add 6.
We could add 6 to both sides. Could I try the GCF thing again?
Yeah.
Is there a GCF?
3.
Yep. We have a GCF of 3. If I take a 3 out of each piece, what would I have left over?
X squared plus 5x minus 10.
And then I could try the X box. I would want 2 numbers that multiplied to give me what?
Negative 2.
-2. But adds to 5. Are there any numbers that multiply to -2 and add to 5? No. So this does not factor. And we have not talked about very many analytical methods. We've got factoring, we've got solving by doing what you were suggesting, Fabiha, where we like add 6 to both sides and we try to work through it that way. But if neither of those work, we haven't really explored any further analytical methods. So what could I do to solve this then?
Graph it.
Graph it. All right, tell me what to type in.
3x squared plus 15x minus 6. Minus 6.
And I want it to be equal to what?
0.
Equal to 0.
Okay, 0 plus
Does it ever equal 0?
Yes.
Yes. It's about where?
5. Right.
Yeah. It's going to be in between -5 and -6, right?
And then in between 0 and 1.
In between 0 and 1. So I'm going to click on the graph to get more precise values, but just looking at the graph, you should be able to ballpark about where these zeros are. All right, so I've got these 2 values here, -5.372 and +0.372. So x equals -5.372. X is equal to a +0.372. And we got to that using a Desmos graph. So like I mentioned at the beginning of class, your first homework assignment since spring break has one problem. Only one problem.
But solve it in many ways.
Solve it in as many ways as you can. So try some different analytical methods. Try graphing. Get in and explore using a table. We didn't touch on that as much this time, but I want to see as many different methods as possible.
Can we upload like a screenshot of it?
Yeah, so you can either type it in or you can work it out on paper or on your iPad or whatever, and then you're just going to upload a picture of it if you don't type it all out there. Yes. All right. This homework is going to be due on Friday because I want to give you guys time to play around with it. And we're going to continue to explore solving methods through the remainder of the week. All right?